Good morning, good afternoon, and good evening, wherever you are. Welcome back to another CIQ webcast. We appreciate you joining. Don't forget to like and subscribe so we can stay in touch with you. And if you don't mind, drop a comment in. Let us know who you are and where you are. I'd like to stay in touch with you if you can. So today we're going to be talking about Apptainer. I know we talked about Apptainer in the past, but I think there's some things that we would like to update you on. And I have Forrest and Robert with me today. Forrest is on mute still.
Good morning, everyone.
Morning, Forrest. Welcome back. Robert?
Good morning.
Thanks for joining. So we talked about Apptainer once in the past. We had Ian and Forrest on to talk about Apptainer, but I think it's important for us to go back and dive into it a little bit and kind of start from the beginning. So can you guys describe to me, what is Apptainer?
So Apptainer is essentially a container runtime that is built to execute and build containers on your architecture that is specifically built with high-performance computing and security use cases in mind. So similar to how we would, might have Docker, Podman, or something like that. It's essentially a container runtime in that same family of software.
All right, so it's called Apptainer now. I know previously it was called Singularity. So I think it's important kind of to be distinct. And are they the same? Are they different? What is that relationship?
So we'll back up a little bit and kind of start from the beginning. Singularity is a containerization technology and software platform that was started on development at LBNL by Greg Kurtzer and his team there about the mid-2010s or so. Going back even farther, high-performance computing is essentially an industry where there has traditionally been kind of a focus on monolithic architectures and the usage of software stacks that are well-defined in that sphere. So in about the mid-90s, the Beowulf model came out for high-performance computing clusters. That's essentially a bunch of commodity computers all linked together with one primary computer, the head node, they call it, managing the rest of those, all the rest of those systems. And with that came, concepts like MPI, which allows you to spread, software runs over multiple different, servers or compute nodes, as we call it, at once. And so HPC has traditionally used a lot of these kind of same technologies, the same job schedulers, that kind of stuff. There hasn't been a lot of ability to bring some of the latest and greatest of different innovations that the rest of maybe enterprise is working into HPC. And a big example of that is containers. Containerization didn't really have a place in HPC before Singularity. It was kind of something that was more used in enterprise, but there wasn't really a good implementation of it in the high-performance computing architecture. And so, as mentioned, this need was recognized because containers are a fantastic piece of technology for high-performance computing because of the portability, reproducibility, security, and other convenience aspects of them that make them very useful for a lot of different things in that sphere. And so, essentially, Singularity was built to fill that container gap in HPC and provide a meaningful way to allow containers to be built and deployed across high-performance computing architecture, with all of those modern benefits, or with all those still ability to use MPI and stuff like that. So in essence, Singularity was born out of a need to bring containers out of enterprise and into HPC as well. And so it was built, it was deployed at many different sites over a few years. It kind of started to gain a very large user base across a lot of different places. There was over, I believe the number out there is 25,000 installs of Singularity at different sites around the world. And so essentially, Singularity continued to develop until about mid last year or so. Singularity is a very mature technology. It's been in development for a number of years. It has a number of different features that, as I've discussed, are very useful. And so there was kind of a question that was put out to the Singularity community at that point that kind of dealt with, what was next? Where should Singularity go? And this question revolved around moving Singularity into the Linux Foundation and allowing it to kind of be in that sphere in a similar way that other projects like Kubernetes and such have ended up, under the purview of different, organizations like the Cloud Native Computing Federation. the question went out as to whether or not Apptainer wanted to be moved into the Linux Foundation. The Apptainer community unanimously approved this. About 50 or so community members were sent the question, should Apptainer join the Linux Foundation? The response from the Singularity community was unanimous from those 50 people that yes, this was a good idea. And so kind of inroads were started to be made there. As a part of that process, it was demonstrated also that there was strong support from industry users of Singularity as well. So places like Intel and AMD had people also that wrote in support of this move into the Linux Foundation. And so with all that, set, and both the community and kind of the, maybe more enterprise or industry side of the Singularity community in approval of it, things went forward. Singularity ended up joining the Linux Foundation. And because of essentially just, legalities around surrounding trademarks and another version of Singularity that's maintained by a third party, a commercial version of Singularity that's maintained by a third party, the name Singularity couldn't continue to be used. And so the project had to be renamed to something. Apptainer was a suggestion that came up, and it ended up winning out among the community. And so now we are here with the initial release of Apptainer, separate from the previous, Singularity development, kind of its own little, what's the word I'm looking for? It's like the next step of it, essentially. It's the open source Singularity has been, development on it has ceased, and it's now moving under the purview of Apptainer. And so that is how we're here with Apptainer.
Thanks, Forrest. I appreciate that. Robert, I'll throw this one over to you. I know most of this was built for HPC, and I know that that's kind of where everything's been focused, but what things are changing, or what has been done now that it's in the Linux Foundation to kind of drive this to the enterprise as well?
Yeah, so in a lot of cases, what we're seeing is a need for the immutability, need for cryptographic signing of applications, the need for software supply chain security, a need for the running traditional HPC type of workloads inside of enterprise AI, machine learning, and other workflows are really driving the need for containerization of those applications. So we're seeing a big growth in that capability, and this is a format that folks are appreciating.
And then as moving this into the Linux Foundation, has that helped with adoption? Is it helping grow capabilities in the enterprise and across HPC? What does that look like, and what is that doing today?
Yeah, Zane, that was one of the biggest reasons to move it there, was to get tighter with Cloud Native Compute Foundation, OpenHPC, the entire Linux Foundation's family of projects. It was an extremely important step, I believe, to expand the reach of what it can do.
Yeah, just to jump in there, you look at some of the other projects that are currently under the purview of the Cloud Native Computing Federation or the Open Containers Initiative, and you see things that have huge effect on the enterprise and increasingly HPC. But we see that these organizations are already heavily involved with technologies like Kubernetes, Containerd, Run-C, all kinds of different. Helm also is another good example. This whole kind of cloud computing as it relates to containers, is really organizing around these organizations. And as HPC increasingly moves into the cloud, having something like Apptainer with the model that makes it good for HPC, things like, for example, its integration over isolation approach. Whereas with Docker or something like that, you'll find that the natural kind of way the container runtime wants to run is in an isolated way, so that the containers are as isolated from the host they're running on as possible. Apptainer is far more focused on integration, because there are oftentimes a lot of kind of specialized hardware and software pieces that are a part of a high performance computing cluster. And so we definitely want those to still be able to be used within Apptainer. So it has very robust support for GPUs, MPI, these things that we need to make available inside of containers so they can be effectively used and scaled in HPC. It also has that single runtime that essentially builds its containers as single flat files that you can move between systems very easily. You can then take and cryptographically sign those containers. You can encrypt them as well, the underlying file system that they're made up from. So Apptainer is obviously, it's something that's hugely focused on HPC. And so as HPC begins to move into the cloud, we see more and more use of public cloud or even private cloud for people wanting to run HPC. We definitely want to be coupling Apptainer as tightly as possible to these organizations that are driving that innovation and driving that development of, as I started by mentioning here, those vital technologies out there like Kubernetes and that kind of thing. So it's definitely a very good thing for Apptainer being, essentially the premier container runtime in HPC, to be a part of those organizations and to kind of be able to make sure that Apptainer is included in making sure that things work with it and such like that. So yeah, there's a lot of cross-pollination that can go on there. There's also as a part of the Linux Foundation like OpenHPC, which is another big project that traditionally is kind of focused around the open source. Like if you go and look on there, they'll talk about Werewolf and Rocky Linux and stuff like that at OpenHPC. So that's something we're very excited to be closer to as well. Being Apptainer and HPC, as I've said a few different times. We're definitely very excited to also move closer to high performance computing focused projects that are part of the Linux Foundation like that.
Great. Thanks, Forrest. So Mike, appreciate you jumping in and being the first one to post that you're listening and where you're from. Greg, obviously joined in too. So we have a good question from Stefano, and he's wanted to kind of compare and contrast. What are the pros and cons of Apptainer compared to Docker for an HPC workload? I think it's an important question, so we probably should distinct.
Absolutely. So as I've kind of touched on a little bit, but I'll go into a little bit deeper. Essentially, the security model and kind of the running model that Docker uses in order to run its containers doesn't work well with a multi-tenant HPC system. So when we think of for example, an enterprise server, we're maybe thinking of something like a web server, where if you don't count, thousands of people that might be accessing your website, the total number of people that are actually going to interact with that server is probably very low. It's basically just you and, the rest of your system administrators. So, half dozen people more, depending upon your organization. You get what I'm saying? Just lost my train of thought.
No. So,
a multi-tenant HPC system.
There you go.
Sorry.
There you
yes. So when we're in an HPC system, we're not in an environment where we can count on just having a select number of very access-controlled users, being on that system at any one given time. A traditional HPC system could have, hundreds of accounts for different users on it to be able to log into it. Typically, what we see is sites will set up a login node, which is essentially a node that is just for users to be able to log into things on. This is done for certain reasons in HPC, avoiding things being run on a head node, stuff like that. But essentially, when you have hundreds of people that are on this node or that need to be able to use these resources, Docker's model of needing to be privileged in order to interact with it falls apart. When you have hundreds of different people, you can't possibly give all those people the level of access with regard to security that Docker requires in order to be able to run it. And so Docker in general just does not work very well in a traditional high performance computing cluster environment. It also doesn't particularly scale over nodes as easy as Apptainer can with its integration for MPI and stuff like that. And so those are a couple of big things. As I kind of touched on, a big focus of Apptainer is integration over isolation. So whereas in Docker, you would have a container that's trying to isolate from the host and kind of present its own file system, its own interface. With Apptainer, when I go and get into an Apptainer container on a compute node or an HPC architecture, I'm going to be my same user as I was outside of that container as I am inside the container. And so you can immediately see how that'd be useful. I can spin up custom environments that have, like we've touched on, AI or ML tooling in them, and then be able to essentially apply that environment to what I'm doing on that HPC cluster. maybe if I'm developing on a node or something like that, I can interact with the files that I own on that cluster directly from inside of an Apptainer. The security model makes it very easy to integrate and do HPC work. Another big thing about Apptainer that I want to make sure I mention is it can lead to much greater efficiency when you're deploying high performance computing workloads because of certain aspects of how it does file input and output. If you can imagine trying to run a MPI job across 1,000 nodes at once, maybe we're running a molecular dynamics simulation or something like that, or maybe something that's using Python, doing a lot of small file I/O imports, that kind of stuff. If you were just doing this on a normal file system, the operating system would be having to seek and look through that file system, traverse directories and stuff to find those files. If you're using an Apptainer, instead, the internal file system that all of the different components that are represented in that container, like I said, the AI or ML tooling, anything system stuff, that's all represented inside of a compressed squash FS file, essentially. And so when you're writing, or sorry, not when you're writing, I'll get to writing in a second. When you're reading from this squash FS and doing this, small file import, stuff like that, the speed of that will be much faster than if you were just pulling it from a standard directory, because instead of doing directory traversals and stuff like that, the squash FS, compressed file system underneath it essentially allows you to just read offsets into that squash FS. So it becomes much faster. The target of your I/O becomes a single file instead of the entire directory structure. And you can get that same thing if you're writing a lot of data by adding an overlay to a container. An overlay in Apptainer is an X3 image, basically. You can add onto a container to add a writable layer to it. And if you target that writable layer with outputs of small file I/O, because you're once again basically just writing data at offsets in an image file, it has that same type of speed than if you were trying to traverse all over a directory and write stuff. So Apptainer has a lot of different benefits over Docker in an HPC environment. Docker is really meant for running services, doing that kind of thing. This is kind of where the concept of like microservices, one container for one small task, came out of. Essentially, the difference boils down to the fact that Apptainer has a fundamentally different model than Docker with how it works. Like I also kind of touched on, it also features essentially a single runtime, whereas in Docker you're going to be, and this touches on kind of the security model of it, as I discussed, needing people interacting with Docker to be privileged. Docker's daemon-based system requires you to manage, starting and stopping that with systemctl or whatever, that whole kind of thing. In Apptainer, the container runtime is essentially a single, executable platform that you just feed in these container images that Apptainer produces called SIFs, Singularity image formats. It essentially, yeah.
Yeah, that's great for us. I appreciate it. Robert, I know one of the other things.
Yeah.
No, you're good. Go ahead.
Sorry, I did want to finish my thought there.
Yeah.
If I can remember. Oh yeah, the runtimes. Sorry. There was a knock at my door a couple of minutes ago, and I'm not sure what it was, and it kind of threw me off a little bit. Essentially, with how the runtime goes, like I said, in Docker, it's a daemon-based system. You have to manage it with systemctl. In Apptainer, it's essentially a single execution runtime that operates over these single flat files. In Docker, you're going to be managing images that are all managed through, like, you can imagine something like Docker image ls, and you'll be able to see the Docker images that you've built on your system. It's something that's inherently tied to Docker. With Apptainer and these SIFs, they can essentially just be treated like any other executable file, especially if you use some of the other features that Apptainer has that literally allow you to use them like an executable and specify what they do when you run them that way. You can essentially treat Apptainers as an executable, and they can be moved, between systems or between, for example, research groups or whatever, with the ease of basically just moving a file around. And then because of the security features that we've discussed, you can also cryptographically sign and encrypt those containers in transit so that you can have, guarantees that, the container is what it is and it hasn't been tampered with at all. So essentially a lot of differences. Apptainer is very different than Docker. So
thank you, Forrest. So on the security side, Robert, I know you like to talk about this quite a bit, is even though, I mean, it's great that you can encrypt the file, so in transit you'll have it, but you've also like to talk about the fact that you can actually execute that thing and it stays encrypted. So at runtime, you can verify it before you execute it, you can execute it, run it encrypted. Am I off?
No, and with the software supply chain being such a crucial aspect to everything now, having multiple signatures to identify that container, similar to what Forrest was just describing as far as sharing, but also now as far as placing that onto resources, right? So when you go place those onto an endpoint or a resource, and you can then run it in an encrypted state, it never decrypts basically out of memory. It gives you the capacity to deliver a solution that it can fulfill an entire life cycle of, say, an AI workflow, all the way from training to inferencing to delivering those algorithms to an edge device to now perform. So it just gives people a way to systematically maintain that software supply chain throughout their entire solution.
Excellent. Thank you.
And so you can imagine, building on that, how, Apptainer could be integrated into, for example, your CI/CD practices to do automatic verification and encryption and security and stuff like that. There's a lot of different ways that you can look at those security abilities, as Robert talks about, use those features to ensure Apptainer's security, across the software supply chain. So very useful features there that are useful in both more human focused, but also more kind of automated settings as well.
Thanks, Forrest. So Misha has a question, and it's talking about vendor-specific container hubs. So like NVIDIA has theirs, AMD has theirs, and then Docker obviously has theirs. Is there any plan to get them to use Apptainer instead of Docker? I think I know where the answer is going to go, but I'll let you answer that for us.
I doubt, I can't really speak to any plans, but I can also tell you that that's not particularly necessary. One big thing that Apptainer is also built with is Open Containers Initiative, or OCI, compatibility. So the standards that they're putting out for things like Docker, Apptainer is fully, Apptainer is fully compatible with. Whereas in Docker, just to kind of explain, how exactly that happens, when you're pulling a container off of the NGC or something like that, we might do a Docker pull and then provide the, pull tag. With Apptainer, it's the same thing. Apptainer pull and then provide, the pull tag and the URL to the container. Whereas in Docker, there's a concept of layers. For example, if you're building a Docker file, every run, copy, or other command I can't remember right off the top of my head introduces a new layer into the container. And that, has other things that, for example, increases like your attack surface with the number of containers or number of, layers that you have in an image. So that's the way those work. But if we're using Apptainer and we do that Apptainer pull, there's no concept of layers in Apptainer. So essentially all of those layers will be compressed down into that single squashfs or compressed squashfs that makes up the core file system of an Apptainer container, aka the CIF. So in essence, there isn't a particular need for them to specifically build it with Apptainer. That'd be great, especially if they're using, especially if this is, HPC focused technology. And I know that, for example, if you go to the NGC and look around, I believe that they give you instructions on how to use both Docker and they'll call it Singularity, but Apptainer to deploy those containers as well. I believe I've seen like tutorials over there. It's just included in their instructions. So there is already a kind of a concept of support for some of them out there. But essentially the most important part of this is Apptainer has full support for OCI images, and pulling those from a container registry is essentially just an operation of taking all the layers that make up that Docker container, compressing them down to squashfs, and then delivering you the Apptainer. So it works just fine with Docker and containers built and deployed on those registries.
Excellent. That's where I figured this was going to go. I just wanted to let you guys talk about it. So I mean, again, Misha, great question. We appreciate it.
Absolutely.
The proliferation of Docker, it was built that way for a reason with Singularity and Apptainer to make sure that you could just pull from those.
Mm-hmm.
So I know that Apptainer 1.0, I believe 1 has been released now, right?
Mm-hmm. And I think 1.0.1 was also released yesterday as well, the next one after.
Excellent. Can you tell us some of the features that are in that?
Yeah, I have a demo here in a little bit as well of one of those, kind of one of the bigger ones that came out of it. So just to kind of go through a little bit of our changelog here, what I'll demo here in a bit is instance checkpointing using DMTCP. That's distributed multi-threaded checkpointing. That is kind of an HPC-focused technology that allows you to checkpoint the state of an application while it's running. And why would you want to do this? If you're running something in HPC, it's entirely possible that this one single run of an executable could last days or even potentially weeks. And so if we're sitting there and we have a simulation that's running for a very, very long period of time, it would not be good to have that, something go wrong with that. I don't know, there's an error in the code that becomes apparent after a long period of time. A cosmic ray hits a bit and flips it and causes the whole thing to crash. There's, then suddenly you've just lost those days or weeks of computational time that you've been waiting on. So DMTCP allows you to do checkpointing of applications. And essentially this allows you to save off the state of an application while it's running and then be able to restore the application to that state at a later period. And so we've implemented this on container instances in Apptainer. A container instance in Apptainer is to it's what you would, let me get the equivalency here. A container in Apptainer is essentially equivalent to what would be called an image in Docker, while an instance in Apptainer, a container instance in Apptainer, is essentially equivalent to what would be called a Docker container. Like this is the concept of, the one-off immutable base copy of an image versus, one-off copies of that image made to do something specific. So like you have a, specific service container and, you're spinning up copies of that to run a service. You can now use DMTCP to checkpoint those container instances and their state in Apptainer. So you can start up an instance, essentially attach a checkpoint to it, checkpoint that application as it's running in that instance, and then be able to restart that instance at any point from that checkpoint and have the state of the application inside of it be the same. So that's very useful. That's a great HPC-focused kind of part of it that'll be very useful for checkpointing workloads running out of Apptainer containers on high-performance computing architecture. Just to run through a few other things here that are a little bit smaller but are still, kind of interesting. There's an option to set up a writable tempfs when you're working with a container, and this will essentially, the container is immutable. It's a read-only file system. So while you can interact with your host file system inside of it because of how Apptainer's security model works, you cannot actually edit the container itself. The container is immutable. This is, the basic concept of a container. You can use a writable tempfs in Apptainer that essentially gives you a temporary file system in RAM to be able to write things to, and that's useful for certain use cases. Nowadays, one of the new features is that when you're doing a build of an Apptainer container, you can take the test section, which is a section that allows you to specify commands that'll be run after the container is built to test it for functionality. So this could be, checking for the version string of different applications or even something more complex. You can now use writable tempfs with this build option to generate a writable space in RAM for the actual build process to use with that test functionality, so that you can use a writable temporary file system with your tests as well on building a container, or once a container build is done. So that's very useful.
Very nice.
For some use cases. Yeah. There's kind of a shorthand flag that implies a few different options that people typically want to use with OCI or Docker containers. So that is kind of just an interesting shorthand there that makes that easier. There was some improvement around the way that GPU libraries are brought into a container. As I've mentioned, one of the big things about Apptainer is that it has support for GPUs and being able to utilize give essentially what's inside the container a GPU to work with. Normally, the libraries that this needs to have bound into the container from the host in order to make this work are discovered via a configuration file that comes with Apptainer, or they're discovered via one of NVIDIA's command line tools, I believe called NVIDIA Docker. Nowadays, there's some new tooling that's come out of NVIDIA, kind of surrounding managing, NVIDIA-based containers and, essentially GPU-based containers. So there's some new support in Apptainer to be able to use their NVIDIA container CLI instead of this pre-made list or this NVIDIA Docker tool, if you specify that you want to use that container CLI tool. So that's kind of a new way to work with GPUs and, with making them or having support for them in containers as far as, the libraries and that kind of thing. So that's very useful for, deploying AI, ML, anything that uses a GPU in a high performance computing environment. There's some differences surrounding how C groups are done. It now supports the second version of C groups and that kind of hierarchical setup as opposed to just the first version of C groups. So that was interesting. And in general, there are a lot of other kind of smaller changes that came out with it. Those are some of the bigger new features that have come out with it. There were some changes to how, for example, some of the internal security options that Apptainer provides work. So, for example, you can do things like set flags on whether or not you want, unencrypted CIFs to even be able to be run within the Apptainer runtime. And so, there's, like I said, there's also other things that gave better support for Docker and OCI images. And in general, lots of kind of internal changes that work on kind of how libraries are found across, not just GPUs as well, but other aspects of binding those into the container. So in general, a lot of different changes. A lot of these changes that came out in the initial release, like I said, we had the initial release a couple of weeks ago. We just had the next release yesterday. So a lot of the changes that were in the initial release were focused on providing backwards compatibility for Singularity installs, which if you're curious about, maybe you haven't made the transition yet to Apptainer, we do have a previous webinar that went over that migration and how that works and what that kind of looks like. So feel free to refer to that if you're looking for kind of a tutorial on what that migration looks like. But in general, the first release was focused around kind of the different things that need to be done in order to provide that backwards compatibility, improving support with Docker and OCI images, improving the ways that libraries are found and presented to the container. And then, like I said, added a few new features, like most significantly, the DMTCP checkpointing.
And I believe that's what you're going to show us, right?
Absolutely.
Let's see it.
So give me just a moment to pull up my VM here and share my screen. All right. Just up that font a little bit more. Okay, there we go. Should be able to see that fine.
Nice.
All right, cool. So I'm here on a Rocky 8.5 box. I've got Apptainer installed, and I've also got DMTCP installed. We'll make sure to provide a link to the pull request that kind of show on Apptainer's repo that kind of shows the basic tutorial I'm about to go through here of how DMTCP works. It kind of has some of the information about how you should install DMTCP. There's you basically want to install it from source, but there's also an option that you want to make sure you use that I believe enables it to use static C libraries or something along those lines. I would have to go and look at the thing again. But anyway, we'll make sure that that link is out there. That tells you how you should build DMTCP and like the options that you should make sure it's built with in order to provide support in this manner and stuff. And then I basically just installed Apptainer. My apologies. I basically just installed Apptainer as an RPM from the repo there. So we'll go ahead and get started on this demo here. I've got my commands here just to make sure that I don't lose them. So the first thing that we'll do is Apptainer checkpoint create, and we'll provide a name of that checkpoint. So we'll just call this example checkpoint. Checkpoint. Go ahead and create that. This creates a file in Apptainer checkpoint. You can see it kind of goes down to this. There's nothing in there right now because we haven't actually done anything with this checkpoint yet. But you can see that's where that data is kind of put at. So we haven't done anything with this checkpoint, but let's go ahead and do something. I have a simple HTTP server container recipe that I have built here that we're going to use with this demo. You can see that this is pretty simple. You can also get this from the pull request that we'll link. If you have any problems with which, and for whatever reason, DMTCP not liking the function that which occasionally is implemented as, this is a workaround, basically just setting an alias there inside of this specific folder. So a little bit of an odd deal there, but if you run into any problems with that, that is a workaround. We'll go ahead and do now with the CIF that I built from this definition. We'll go ahead and start a container instance of it. As I mentioned, we have the base CIF that is our container in this case, or that, is essentially our container in this case. And then we're going to start an instance of that container that's essentially a one-off copy of that, that is, like I said, comparable to a Docker container, or a Docker container running a service based on a Docker image. So I'll go ahead and do, let's see, Apptainer instance start. And I'll provide the DMTCP launch flag to let us know that we want DMTCP to be set up inside of this container to be used as well. We'll provide the checkpoint that we want to link to it, which is the one that we just added, or the one we just created, example checkpoint. And then we'll go ahead and provide the path to the container CIF that we want to make this container from, or we want to make this instance from. So we do server.cif because it's just here in the same home directory that I'm in. And then we'll go ahead and provide the name that we want this instance to have. And then you'll notice down here, we have a start script. This is what this container is going to run when an instance of it is started. So in this case, you can see that we have Python 3, and we're just going to run this code right here, basically. And then we're also going to pick up an option from the start of the instance. So in this case, that option will come from right here. So we'll provide the port that we want this to connect to here on our local host there on the command line. So we'll see that we have the instance started successfully. We should at this point be able to curl localhost 8888 and get a response out of it. Pretty simple one, but still a response. After that. So you can see we get a 0 printed out of this. This, like I said, is a very basic example, but you can see how if we can checkpoint applications like this, it would be very useful across HPC. So this is currently serving us at a 0 when we do that curl command. We'll send a post so that we can, sorry, I've got two monitors here. We'll send a post so that we can change that to just a 1. And then we'll go ahead and curl that again. And you'll see that that's now changed. We're getting a 1 out of it. At this point, we've changed something about the way that this instance is running, so we can actually checkpoint it. And so we'll do Apptainer checkpoint instance server. And so, as I mentioned, the name of this instance is server. So we're just referring to that instance here and telling it to checkpoint it with the checkpoint that we set up, which is example checkpoint. So we'll go ahead and do Apptainer checkpoint instance server. You can see we get info telling us what checkpoint we're using. And then we'll go ahead and stop the server. So normally, this would essentially wipe away the state of the server. Where's the name? There it is. normally this would essentially wipe away the state of the server. And if we restart this off that same image, per the concept, it'll basically create a new and unedited copy of that base CIF container. But because we're using DMTCP checkpointing, we'll be able to restart this container instance here in a second once I put the command in and everything. Here in just a second, we'll be able to restart that instance based on that checkpoint. We'll be able to see that immediately once that data is loaded. We're able to actually see that 1 being printed out again, as opposed to the 0 that it was before, even though we're creating this container instance from the same base container that we were using before. So we would expect it to be 0 if we weren't using checkpointing. So I'll go ahead and put the next command that we need in here. We do Apptainer instance start DMTCP restart, which in this case tells it that we're looking to restart a previous checkpoint with this instance that we're spinning up. We'll then go ahead and provide the same name of the checkpoint that we used before. And actually, really quickly, I'll show you. You can see now that there's data inside of that Apptainer checkpoint DMTCP example checkpoint. So that's how you can kind of have some visibility into what the checkpoint looks like. For example, you can see the restart script there and stuff. You can see, like I said, for example, the restart script that's about to restart this checkpointed instance, basically. So we'll go ahead and provide, I'll go ahead and copy this. So go ahead and provide Apptainer instance start, DMTCP restart example checkpoint, and then we'll call this restarted. Well, actually, hold on. Do server.cif, and then we'll do, we'll just name this something else. We'll call it restarted server, and then we provide the same port. And when we do this, yes, that's correct. When we do this, this instance will restart. And you'll see that instance starts successfully. And then here in just a second, once DMTCP loads all that memory and stuff for that application, we should be able to curl this again and get the 1 that we previously saved out of this before. So we'll go ahead and do this. And you can see we get that 1 out of there. And we've essentially checkpointed this instance. So yeah, that is the DMTCP checkpointing. Just to once again reiterate what I did there, I created a Apptainer container instance of this server.cif Apptainer that I have here. I changed some data in it. I checkpointed that with that Apptainer, Apptainer checkpoint instance server. I checkpointed it with that. I shut that server down. So when we restart or if we were to restart another server off of that, without doing this checkpointing, we would get, it would curl 0 in that case because we're making a copy of what's already there without the modifications that we used curl to post to it. And so once those changes were made and it was checkpointed, we were able to restart that instance then and have its state essentially, or the state of the application inside of it essentially be saved and be able to be redeployed with that instance. So you can see how that would be useful for a wide variety of different use cases, especially things that are long running and are using this instance framework. So yeah, that is DMTCP checkpointing in Apptainer.
Thanks, Forrest. That's great. It's very interesting and cool to see actually in progress.
Very neat.
So as we come to the end of this, Robert, what is CIQ's role in Apptainer?
Yeah, we're definitely stand behind it as one of the members of the Linux Foundation and have multiple folks that actually contribute to the solution as others. And we do have a full commercial offering around helping people utilize it and get the most out of the solution. Yeah, I mean, CIQ is definitely standing behind it in all ways. Additionally, I'd also say is we're actively growing our team extremely fast, hiring on folks that can, take solutions like this and help customers execute. So this is something that CIQ is committed to doing.
Excellent. I know, Robert, if you want to touch on kind of the support model that we have and the way that we approach that.
Yeah, definitely. So, our core ethos is to support people and empower people. So our model is based on that. So it's based on the number of people that need support and help in your organization. We do have other ways to structure that might be more beneficial for you, but that is the best way we've seen yet, is to really work with the individuals that are using it in order to make them successful, which then makes their organization successful. We found that to be the most direct way to do it. And, we're in this to help people and empower people. So at the end of the day, we thought our support and structure and our services model should represent that.
Yeah, it's definitely something that I haven't seen in the industry before. It's very interesting, and it seems to be getting a lot of interest instead of having to count everything and keep track of everything. So it's a great model. Thanks, Robert. So Patrick, I know Patrick Roberts posted in there that he had done they do smoke testing, EDA smoke testing after a build. So appreciate that comment in there, Patrick. So we are at the end of time, guys. If you don't have any more questions, like Robert said, we're growing very fast. There's a lot of openings out there on our website. Go check them out. I think they just got posted to links for the jobs that are out there. Looking forward to hearing from you guys. Again, don't forget, like, subscribe so that you can stay in touch with us and we can keep track of you. I appreciate the time today, guys. We'll hang out for another minute, see if we have any other questions come in. Maybe. I like the new background for us.
Thank you. Very nice.
And Robert got a haircut. All right. Well, we appreciate the time today, folks. Join us again probably next week for the next topic. Thank you very much. Talk to you later, guys.